Okay, everybody, here we are, 3.8, solving problems with fractions. I put this chart here because we're solving word problems with different functions or operations, sorry, and we need to be able to decide what operation we want to use. So addition, subtraction, multiplication, and division are all operations. That's when we say order of operations, that's what we mean. And I just wanted to include some keywords that you might notice suggests the operation you need to use. So for addition, you can look for add, sum, total, altogether. That often suggests it's going to be an addition question, not always, but often. For subtraction, we have difference, loss, what's left or remaining. For multiplication, we obviously have product. That's the answer to a multiplication question. Of is a huge one. If you're looking for a quarter of, 2/5, it's going to be a multiplication question. Often, if it's asking about the area, remember that's length times width. So that's often a multiplication question. And times we're pretty used to seeing. Quotient is the answer to a division question. That one makes sense. Divide, pretty common. We know that one. I think how many times can this, goes into this? And often the word split can suggest division as well. So not all of the time. And actually, I think I'm going to put up some posters in the class, and we can kind of try to keep a record or like a running total of words. We can make a collection of all the words that often mean certain operations. But there you go. So let's do a few questions together. And so before, we were learning about something like specifically dividing or specifically multiplying. But now we have kind of the additional part of deciding which operation to use. So let's go. Estimate to check if your answer makes sense. During a 1-hour phone-in talk show, 8 callers made calls that took 3 minutes and 3.25 minutes each. So roughly, if we're going to estimate, it's roughly going to be 8 times 3. So, about 24, but more than that because we also have those quarters. So how many minutes were used by 8 callers? We need to find 8 times 3.25. Sorry, that's a half. Let's make this into 8/1, and let's make this into a improper fraction. So 4 times 3 is 12, plus 1 is 13/4. Then I'm going to multiply the tops. 8 times 13 equals 104. 104. I also could have cross reduced. Let's do that. So 4 can go into 4 once, and 4 can go into 8 twice. There we go. That's way more manageable. Now, 2 times 13 is 26, and 1 times 1 is 1. So 26 minutes. And try to actually, don't just have your answer as 26. It's asking how many minutes were used. So it's good to put the units. So it's 26 minutes. The next one, what fraction of the hour was used by these callers? So we used 26 out of 60 minutes. Okay, 60 would be an entire hour, and we used 26 of them. So that's a fraction for the hour. Looks like we can reduce that because they're both even. So let's divide top and bottom by 2, and we get 13/30. Okay, so there you go. That's the fraction of the hour that was used by these callers. Next, how many minutes were left for other callers? Okay, so let's look at the word left. Let's scroll up. Not always, but in this case, it's true. This is going to be a subtraction question. So we start with 60 minutes in an hour. We can subtract the minutes that were used, and the difference is what's left over. So 34 minutes. And finally, what fraction of the hour was left in the talk show for other callers? So we just answered that question there. and we need to just relate it to the entire hour. So 34 out of the 60 minutes are left. Looks like they're both even, so we can reduce by 2, and that is 17 over 30. And that also makes sense, if we used 13 over 30 minutes, then 17 over 30 minutes being left makes sense, because if you add those two together, you would get 30 over 30 minutes, or, that's a fraction, because I guess it's actually an hour, which is the same as, 60 over 60 minutes. Okay. So let's do a few more questions. Miss Lecky ordered pizza for a party, 1 5/8 of the vegetarian pizza and 2/3 of the ham and pineapple pizza were not eaten. Okay. How much pizza was left? Oh, and I think on your version, I added left altogether. Question mark. So I wanted us to highlight our words a little bit. So I added all together for you, because if you scroll up here, you can see that all together is often, a lot of the time, an addition question. So we have 1 5/8 of a pizza left over. I don't know if 5/8 of a pizza is going to look like. There's 3/4. That's, I think, 5/8. Is that right? Don't quote me on this. Let me do this again. There's 4ths, there's 8ths. 1, 2, 3, 4, 5. Okay, left over. So this part is eaten. This part is no longer. That's gone. There we go. Okay, and 2/3 of a ham and pineapple pizza would look something like this. So this part's still there, this part's still there, but that part is eaten, no longer. So that's how much, and we got to figure that out all together. So we're going to add these. So we have 1 5/8 plus 2/3. Okay, so we're combining some new ideas and some older ideas. So addition, I think you will have learned this in your past grade 7, means that we have to have the same denominator, but we also have to combine our understanding of converting mixed numbers to improper fractions. So let's go 8 times 1 plus 5. That's 13 over 8 plus 2 over 3. And now we have to ask ourselves, okay, what's the first number that both 8 and 3 can go into? 8 goes into 8, 16, 24. 3 doesn't go into 8, doesn't go into 16, but it does go into 24. So let's, I'll do this in a different color. Multiply here by 8 and by 8. And then let's multiply here by 3 and by 3. We get 39. That's 3 times 13 over 24. That's 3 times 8. Plus 2 times 8 is 16 over 3 times 8 is 24. Now this can be tough because we're, remembering lots of things all at once. Because in multiplication, we multiply the tops and multiply the bottoms. However, in addition, we are only going to add the tops. Let's do that. 39 plus, 24, 16, 55. So that equals, I'm going to write it down here, 55 over 24. And now we can convert this to a mixed number. So it can go in there twice. That brings us to 48. 24 times 2 is 48. And it looks like we have 7 over 24 left over. So altogether, there were 2 7/24 pizza left over. There you go. Okay, let's do the next one. I'll try to figure it out. A dressmaker needs 3 3/8 meters of fabric to sew one dress. How many dresses can the dressmaker make with 28 meters of fabric? So let's think about it. Look, we got 28 meters of fabric, 28 meters. And roughly, kind of close to 3.5 almost. Let's say closer to 3, 28 divided by 3. So roughly 9, and probably like a little less than 9 because I just rounded down to 3. So around 9 less than. Okay. So you would, cut it up, I don't know, however many times, but you would expect about 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, ish, right out of there. So let's do it. We are looking at 28 divided by 3 3/8. So let's do 28 times, let's convert this. Actually, I want to show that step. Divided by, let's convert this. 8 times 3 is 24, plus 3 is 27 over 8. Now let's keep, change, flip. 28 over 1 times 8 over 27. I don't think we can cross reduce, so let's do it. 20, I can't see. 28 times 8 equals 224 over 27. Now to convert this to an improper fraction, or sorry, a mixed number, let's go 224 divided by 27, and we get 8 is our big number. And okay, so now let's go 27 times 8, we get 216. And this subtract 216 is going to give us our top part, our numerator. That seems to be 8 over 27. Okay, so around 9, I think that is not a bad estimate of mine, but less than, so I think that's fair. Okay, last question. A dock is 7 3/4 of a meter high. Okay, we can draw a nice dock here. I like to draw a picture for word questions. I don't know, it's nice. Okay, you got a dock. Here's the water here. A portion of the dock above the water one day was measured at 2 meters, 2 2/5 of a meter. And they want to know how much is under the water. Okay, so the dock goes way down. They want to know how much of this is under the water if the total is 7 3/4. Okay, so this is the whole dock. We need to find just this portion of it. So what we're going to need to do is minus. This is our total. If we minus this, we should get this part that's underneath the water. Okay, so do I have room? I do. Let's go 7 3/4 minus 2 2/5. Let's convert them both to improper fractions. 4 times 7 is 28, plus 3 is 31 over 4. Subtract, let's go 5 times 2 is 10, plus 2 is 12 over 5. Now we need a common denominator to subtract them. Remember that. I think the first thing that they can both go into is 20. So we need to times, make the common denominator. So let's times by 4, times by 4. Over here we times by 5, times by 5. So let's do our new ones. 31 times 5 equals 155 over 20. And 12 times 4, okay, this is minus. 12 times 4 is 48 over 20. Now I'm going to subtract just our tops, 155, subtract 48, and we get 107 over 20. Now we got to convert this to a mixed number. 20 can go into 100 5 times, with 7/20 left over. So that's how many, and I should put meters. So that's what we're talking